Lesson 6.2, Properties of Parallelograms. Theorem 6.1 states that opposite sides of parallelograms are congruent. When I look at the parallelogram to the right, I see that segment AB is congruent to segment DC, and segment AD is congruent to segment BC. This is Theorem 6.1. Theorem 6.2 says that opposite angles of a parallelogram are congruent and same side interior angles are supplementary. So angle A is congruent to angle C and angle B is congruent to angle D. We can also say that the measure of angle A plus the measure of angle D equals 180. We can say that the measure of angle A plus the measure of angle B equals 180. The measure of angle B plus the measure of angle C equals 180. And lastly, the measure of angle D plus the measure of angle C equals 180. LMNP is a parallelogram. I need to find the measure of two angles and I need to find the variable D. Well, Theorem 6.1 lets me know that LM is congruent to PN, or the measure of LM equals PN. So I can say that 2D equals 22. And then when I solve for D, I find out that D equals 11. All right. I also know that angle L is congruent, or PLM is congruent to angle M in P, or that their measures are the same by Theorem 6.2. So the measure of angle PLM is 66 plus 42, or the measure of angle PLM is 108. To find the measure of angle LMN, I know that angle LMN and angle MNP are supplementary, meaning they add up to 180. So the measure of angle LMN equals 180 minus 108, or the measure of angle LMN equals 72. Theorem 6.3 says that the diagonals of a parallelogram bisect each other. That means that SU is the bisector of RT and RT is the bisector of US, meaning that segment RQ is congruent to QT and segment UQ is congruent to segment QS. Find the values of X and Y in parallelogram KLMN. Well, Theorem 6.3 lets me say that KA equals AM, or 2X plus 5 equals 5Y, and 7Y minus 16 equals X. So I can use substitution, and wherever I see the variable X, I can substitute in the value 7Y minus 16, since that variable is already isolated for me. So 2 times the quantity 7Y minus 16 plus 5 equals 5Y. When I distribute, I have 14Y minus 32 plus 5 equals 5Y, or negative 27 equals negative 9y. So y equals 3. Now I'm going to take the value of y and substitute that back into the 7y minus 16 equals x. 7 times 3 minus 16 equals x. 21 minus 16 equals 5. So x equals 5. Theorem 6.4, if 3 or more lines are parallel, so if line AB is parallel to line CD is parallel to line EF, and they cut congruent segments, meaning that AC is congruent to CE, then the other transversals segments are congruent, meaning BD is congruent to DF. In the figure at the right, DH, line DH is parallel to line CG, is parallel to BF, is parallel to AE. And then I know that AB equals BC equals CD equals 2. So I'm going to mark all of those measures as 2. And then EF is 2.5, so that means that FG is 2.5 and GH is also 2.5. I'm asked to find EH, and so that's actually 2.5 times 3, or 7.5. All right, and that's your homework assignment. Page 297, 7 through 16 all, 24 through 32 even, 35, 36, 46, 49, 52, and 55. And that is it.